we can right click in the empty space, get Blackboard. The first thing we're going to need is to add a new component called pawn sensing. But this is a great start. You can have an enemy see a player and begin chasing after them. Wow, did you get all that? Alright, we're going to make a character chase another character. Let's do it. Let's start off with the core components that will be involved in the AI decision making. The first is going to be a behavior tree. So let's right click in our content browser, go to artificial intelligence, and create a behavior tree. I'll name it BT_enemy for behavior tree enemy. Then we can open this up. Then we can click on new Blackboard to create a Blackboard that will be linked to this behavior tree. As you can see, currently it has no Blackboard, but once we click this, and we'll name it BB_enemy for Blackboard enemy. Save, and now we have access to our Blackboard within this behavior tree. The Blackboard stores data the AI uses to make decisions, so we can add new keys here of different types to store data and use as we need it. The behavior tree will determine how the enemy should act in given scenarios. Next, we'll need an AI controller to host this behavior tree. So we'll right click again, select Blueprint class, and search for AI controller. Select this one, AI controller, and I'll name it AC_enemy or AI controller enemy. Now we have our three main components to handle the enemy behavior. Finally, we'll need an actor blueprint to represent our enemy in the world. And I'll make this a character so it has the ability to walk around. I'll name it BP enemy for blueprint enemy. So now that we have our four main components that will determine how our enemy acts in the world, let's work backward from how we created them. So I'll open up the BP enemy and I'll give this a skeletal mesh so that we can see what it looks like in the world. I'm gonna give it the tutorial TPP guy that is in all the projects. Whoa, why is that? There we go, that was weird. And I'll lower it down a little bit to align it with the hitbox and rotate it so it aligns with the arrow. And I'll give it an animation blueprint that I made in the previous video, just so we can better understand what the enemy is doing visually. Now we need to tell this enemy actor what controller it uses. So let's go into the class defaults of the blueprint and search for controller. And under the pawn section, we have AI controller class, currently using AI controller, but we have our AI controller enemy here that we've made and we want to use that. So we're going to select that, compile, and save. Our enemy is good to go. We've given it a visual appearance and we've linked it to our AI controller. Let's head to the controller next, and we can use this button to quickly jump to it and open it up. For now, the main goal of our AI controller is going to be running the behavior tree. I'm going to right click to get the onPossess event, and I'm going to drag out to get a run behavior tree node. And in the BT asset, we can open this up and we'll see our behavior tree enemy asset here. We can select that and we should be good to go here. Compile and save. Continuing to work up, we're now ready for our behavior tree and Blackboard. We're going to do a very simple behavior to verify that everything is working as expected. First, we'll need a value in our Blackboard, a new key of type vector. I'm going to name it target location. Save and head back over to the behavior tree. Next, I'm going to drag down from root to place a new node. And when you do this, you'll have a few options that you can select. You have the selector, and if you hover over it, it'll tell you how this node behaves. And then you have the sequence, and again, hover over it to understand how it works, and a simple parallel. For this case, I'm just going to use a selector. And I'm going to drag down from the selector to create another node, and we have several more options at this point. I'm only going to use the move to for now, just to verify our behavior tree is working as expected. I'm going to select move to, which tells our AI to move to a place, and we can specify more information about that in this section here on the right. In the Blackboard section, there's a Blackboard key, and we can change the value from self actor to target location. And it's important to note that the target location as a vector value will not be initialized to 0, 0, 0. In the very beginning, it will be an invalid value, so we will have to set this to give a location for the AI to move to. So a simple way we can do this and verify everything is working as expected is head into the blueprint enemy, into the event graph, and in the begin play event, we can supply a location for the target location. We can right click in the empty space, get Blackboard. This gives us access to the Blackboard for this character. We can pull off of the Blackboard to set vector, set value as vector. We select this, and now we can set any vector value by key name to whatever we want. So in this case, I'm going to create a literal name and set it to target location. And now the vector value will just be 0, 0, 0. So let's try this out. Compile, save, head back over to the map, and we'll want to add a NavMesh to give a walkable area to our AI. So we can search for NavMesh in the Place Actors tab, which if you don't have, there's the window section up here, and the place actors can be toggled here. I'll drag the NavMesh bounds volume into the scene, and I'm going to reset its location to 0, 0, 0, and scale it out 10 by 10. And that should give us a pretty good range to work with. And with the viewport focused, we can hit P to enable the walkable area that the NavMesh is providing. If you do not see a green overlay anywhere, then your NavMesh is not currently working as it is, and you might need to adjust it. Well, you definitely need to adjust it. So I'm going to hit P again to remove that, and we'll drag out an enemy here, reset to 0, 0, 0, drag it up and hit the N key. N key will drop an object down to the ground like that. So this is the position that the AI should walk to. Let's rear it back a bit and simulate the scene to see if it does. And there we go. If we stop this and head back into our behavior tree here, we can hit Alt-P, and we can see that our behavior tree is in fact working, as the AI repeatedly attempts to move to position 0, 0, 0, where our player character is currently standing, so there's a bit of a mess here, but that's all fine. Everything else is working as expected. Now that we have an enemy with memory and decision making, let's do something a little bit more interesting. I've got my simple character here that basically looks the same as an enemy right now, but we can get the enemy to see our character, commit that character or that location to memory, and follow the player or head to that location. So let's try that. Let's head into BP enemy, and the first thing we're going to need is to add a new component called pawn sensing. It's right here in the list, pawn sensing component. I'll click to add, and I'll leave it named as pawn sensing for now. If you head into the viewport, you can see the pawn sensing. My goodness, it's very good at sensing. And we have an AI section on the right in the details panel. There's a hearing threshold, which if you modify this, you can see what that affects and the general visual range of that setting. So then we have the sight radius here, which is at 5,000, as well as the peripheral vision angle. We can decrease the angle to have a smaller cone of vision, or we can keep it very wide and it has a wide peripheral vision. For now, I'm just going to leave everything as default. Feel free to tinker with it as you like. But it would be good to review everything in here and the options you have to control how your AI would sense either pawns or players. And we do have some events down here at the bottom in the events section. And one that we'll be utilizing is on-see pawn. So let's click this plus button, and we get our on-see pawn event. That gives us a pawn, the pawn that was seen. And since we have a target location for now, let's disconnect this from the begin play, and we will wire this up to the pawn sensing. On-see pawn will pull from pawn, get actor location, and we'll feed in this value to the value of target location. So let's compile this, and we'll head into the map, bring an enemy back out, and if they're facing to the right, put them in front of the player, so we shouldn't be seen at this time. And we can see the same pawn sensing range in the map as well, so that can help you judge what you might need to adjust about the pawn sensing. So if I hit play here, we've got our enemy standing here, and I'll walk in front of him, and he is now going to my location at the intervals of the pawn sense. Every time he sees me, my location is being set to the Blackboard target location, and the default interval is 0.5, so it's every half second, which you can speed up if you'd really like, but you don't really need to do a location-based follow like this. It's not really the best, and there's a better option. This time, instead of using a location, let's head back into our behavior tree, go to the Blackboard, and instead of a target location, we'll do an object, and we'll say target actor. And we can specify in the key type of object that the base class is an actor. And you can give a default value if you like, but we're not going to do that. So let's head back into our behavior tree, and we'll change the move to from target location to target actor. We'll save this, head over into the blueprint enemy, and instead of setting a vector to actor location of the pawn that we sensed, we'll instead set object, set value as object, this into the on-see pawn, hook in this key name and change it to target actor, and we'll pass our pawn in as the object value. And now at this point, on-see pawn, which we have our sensing interval here at 0.5 seconds. Every 0.5 seconds that it will check and see if the player is in its sight range, and if it is, this event will execute, passing the witnessed actor in here, and we will be saving it to our Blackboard under the target actor key, in which case we will move to target actor. So let's give it a shot and see how it acts differently. Oh my gosh. I can't get away. Ah! Far more responsive now that it's moving directly to an actor rather than a location key. Did I walk outside the range there? Yeah. The invisible gate. Very quickly, I'm going to lower the speed of the character movement. Max walk speed. It's currently at 600, the same as the character. I'm going to change it to 400 so it's a little bit slower, and play it again here. There we go. We can see how it updates a little bit more nicely now since it's not right up on top of the player character. It updates a little bit better than what it did when it was doing the 0.5 location interval. And of course there's things you can do to make the rotation smoother, have it always facing the player. A lot of nice little quality of life changes you could add to improve how that looks as well. But this is a great start. You can have an enemy see a player and begin chasing after them. A mechanic you'll find in almost any game with enemies, surely. It's basic, but it gets the job done. Now, one little cleanup here before ending. Let's add a decorator to this selector. And if I right click here, go down to add decorator and Blackboard, a decorator node that bases its condition on a Blackboard key. So if we select this, we now have a new little component node in our selector that will gate whether or not this activates. So we can select this, and in the Blackboard section, we have a couple things we can work with. There's the key query, which the options are is set or is not set. Then we have the Blackboard key, currently self actor, target location, target actor. So we can set this to target actor is set, and we can name it here so it displays the information a little bit more cleanly in the board. Sees a target. Alright, and now I'm going to clean this up a little bit here to give it a little bit more functionality within the behavior of our enemy character. Currently, our move to is the only thing we're doing. We're checking to see if we have a target, but it doesn't even really matter because we can't do anything else otherwise. So we only care to move to the target if we can see the target. So let's pull this decorator down into the move to, and we'll pull this to the left as we want it to be our primary action, and then we'll drag from selector to create another action for when we do not see a target. And we'll just call it wait. So we start this now. They're waiting. I walk out in front. We can see that the target value changed to top-down character. And once they were done waiting, they checked back from the top of their behaviors, and this node passed this time. So in a situation like this, you can see these 1, 2, 3 here. The root will activate, activating the selector. The selector will work from left to right. In the very beginning, the selector will activate its number 1 node and see if we see a target. We will not see a target, and we'll see that if we hit play, we can see that there's a red border here, and the value is none, fail. So we're ending up on wait. And after 5 seconds, we can see a slight flash here to where it tries to do this again, fails again, and continues down into wait again. So while it's waiting, I'm going to run across in front of it. We can see target actor is set, value BP top-down character, and it's passing now. The wait time completed. It tried to run the beginning tree again, and it passed this time. The only problem is that there's that delay. They see the target, but they keep waiting. So what we can do to fix this is within the decorator, observer aborts. Currently set to none, you can set it to self, lower priority, or both. And this can happen on value change or result change. So if your enemy could switch targets, you'd want it on value change. But if you're only ever going to have one target, it's just going to become pass or fail, right? You're going to see the target or no longer see the target. So I'm just going to use result change for this case. In the observer aborts, I'm going to set to lower priority. And now we can see this node turned blue. Nodes aborted by mode, lower priority. So now, when we do this again, even when it's doing that 5-second wait, it's not going to wait along until that full 5 seconds. It's going to stop and begin working on the higher priority task. And there you go. You have the knowledge to implement a very basic enemy chasing behavior. The foundation of all enemies in any game with enemies, probably. So if you've been following along with any of the previous videos, you've got a character that you can control and walk around, shoot some projectiles. You've got an animation blueprint to make it look a little bit better, and now you have an enemy that can see the player and chase after them. Almost a full game at this point. Keep adding these building blocks to your toolkit and you'll be able to rapid fire throw Unreal games together like crazy. And then it's just up to you to create and have fun. So if you did find this video helpful at all, leave a like, leave a comment. If you have better suggestions on how to approach anything or just feedback at all, leave me a comment, let me know what's going on, and sign up for the newsletter in my description to get access to any builds that I'm putting out, and subscribe and ring the bell to stay tuned for my next video, which is going to be a devlog about the things that I've been working on.